Greetings to everyone. Welcome to Datagaps webinar. I'm Puja Gupta, Growth Marketing Manager at Datagaps, and I would like to thank you all for joining us today. Before we get started, we have a couple of quick housekeeping comments. First, we have muted all mics to avoid unintended distractions. Next, we have included a couple of polls which will reflect in the middle of the session from time to time, and we would request every attendee to share their feedback by answering those poll questions. And finally, at the end of the session, we will open it up for Q&A. Today in this webinar, we will see how leading enterprises reimagining reconciliation are using Datagaps DataOps Suite, a cloud-native intelligence solution combining ETL validation, BI testing, continuous data quality monitoring, and automated workflows into one powerful platform. On the panel today, we have Anand Rao, VP of Product Marketing at Datagaps, and Shubhanshu Dixit, Product Manager at Datagaps. With this, I hand this over to Anand. Anand, you have the spotlight now.
Great. Thank you, Pooja. So hello, everybody. Thank you for joining us today on this webinar on redefining data reconciliation. I'm sure you guys are very excited to be here. And let me walk you through the agenda. So we'll start with why data reconciliation is important, especially in today's complex, fast-paced data environment, where accuracy and trust in data are not negotiable. Then we'll explore the key industry drivers from regulated, all the regulators and the growing need for continuous cross-system validation. Next, we'll examine some real-world cases across industries like financial services and healthcare. And then we'll go through the various types of reconciliation, transaction level, balance, decomposition, and more. And then we look at why the legacy tools are falling short and what that means for organizations struggling with the scalability and the automation. We'll introduce the DataOps Suite and we'll walk through a demo and a roadmap for adoption. So at the end of this, you will have some concrete next steps for your organization. So before we dive deeper into all the reconciliation workflows, let's look at some of the key fundamentals of data quality. So there are three foundational dimensions we focus on: accuracy, comprehensiveness, timeliness. So accuracy means that the data correctly reflects the real world entities or events. Think of an employee phone number. If it's wrong in the system, any outreach fails, decisions based on that data are compromised. So reconciliation ensures that the accuracy between systems is there and it flags any inconsistencies. So comprehensiveness ensures that all the necessary data is present, nothing is missing. For example, if customer addresses are incomplete in the CRM system, it affects the communication, the segmentation, the analytics. So reconciliation detects gaps like these, especially when integrating different systems. And here's the key point, and I've listed it on the slide as well. If your data isn't comprehensive, reconciliation results can't be trusted. The process will either miss the discrepancies or raise incorrect alerts. So ensuring this data comprehensiveness is a requirement for meaningful and reliable reconciliation. And then there's timeliness that focuses on whether the data is up to date and available when needed. So reconciliation ensures that as well. But the key factor is about comprehensiveness and not raising incorrect alerts and not missing any discrepancies. So at a high level, let's look at why data reconciliation matters. So it's a critical function in modern enterprise operations, ensuring the consistency, accuracy across systems like ledgers, billing systems, healthcare records. So it plays a foundational role in maintaining the data integrity, building the trust, meeting compliance requirements. So there are different regulations from bodies such as SEC, the HIPAA regulation, the Federal Reserve Board. These often require the reconciliation process, and also there are audits that are done like FRB 1419, which demand not just the audit logs, but the entire traceability and the documentation behind the data. So the industries rely on reconciliation to eliminate any discrepancies, whether in financial trades, patient data, or analytics reports. So making it essential for not only reducing risk, but improving the agility of operations. So the approach has evolved from manual checks to more automated controls and digital audit trails. So enhancing the visibility, reducing the human error. And so these tools document the data lineage, they apply the policy checks, and support overall readiness for any audits. So modern data reconciliation also emphasizes traceability. So by decomposing any final regulatory reports into the underlying components and controls, organizations can verify the source, the logic behind every reported figure. And so this ensures that they are not just accurate, but explainable. This is an important requirement for internal governance, external regulation. So in short, data reconciliation is no longer a safeguard. It's more a strategic enabler for trustworthy, compliant, and data-driven organizations. Now let's look at the key industry drivers shaping the importance of data reconciliation. First, of course, are the regulatory requirements. They're more demanding than ever. We have SOX, we have MIFID, Basel, FRB 1419. There's also IFRS. So all these are in finance. And then on the healthcare side, you have HIPAA, high-tech, APCD, and organizations must reconcile all the data accurately and consistently. So not complying brings severe penalties and other operational risks. So second is today's complex data environment. Ensure enterprises operate across hybrid and multi-cloud environments and systems, and managing data from the ETL pipelines, from the APIs, from the SaaS applications. Traditional tools can't handle this kind of fragmentation and the scale of these data ecosystems. Third is the pace of business is accelerated. So waiting for monthly or batch reconciliation is no longer a viable option, and organizations need near real-time validation and continuous monitoring to stay agile and prevent cascading issues. And finally, there's the pressure of audit readiness. So enterprises must deliver full traceability from the final report back to the source system. And this includes documenting lineage, controls, policies, all ensuring that there is transparency for both the internal teams as well as the external auditors. And so these four forces are the regulatory pressure, the data complexity, the velocity of doing business, and the audit requirements are converging to make reconciliation not just a safeguard, but a strategic necessity in modern data operations. So what does reconciliation look like in practice? So in financial services, it ensures the end-to-end traceability. For example, FRB regulatory reports must link back to the trading platforms. So if the trade details don't match across front office, risk, and back office systems, it can lead to settlement errors, reporting discrepancies, or even regulatory violations. In retail banking, so reconciliation keeps all the customer transactions in sync across all the branches, the ATMs, the mobile apps. Any delay or inconsistency in updating balances can erode the customer trust and introduce reputation or financial risk. In healthcare, it aligns electronic health records with billing and insurance claims. So a diagnosis must match the billing code submitted, otherwise, claims may be denied, causing the delays and compliance issues. So accurate matching of APCD and CMS claims with the ICD or CPT codes is very critical. And across industries, the challenge is the same. Multiple systems transform the data independently, and without reconciliation, inconsistencies creep in. So, this is where cross system controls and observability tools are needed. They enable the early detection of these inconsistencies and enable the correction of issues. So this is where modern platforms like Datagaps stand out by automating this whole reconciliation process, enabling the early detection, equipment teams to prevent issues before they escalate. Now, let's look at different types of reconciliation. So there's transaction level reconciliation, which is the most detailed. It compares line by line data like purchase orders to invoices to or trades to settlements. So this type is essential when granularity of the data is needed and root cause analysis is required. So next is balance reconciliation, which compares the summary level values such as account totals or inventory balance. So it's faster but less precise, and it's often used in financial reporting or end of day summaries. The next is data pipeline reconciliation. It validates the transfer of data between systems, like from an ERP system to a data warehouse via a ETL pipeline. So it ensures data isn't lost, altered, or duplicated during this movement across different systems. And then field level reconciliation checks based on specific fields like ID, date, or amount, and supports thresholds or tolerances. It's for catching subtle mismatches and can scale efficiently with automation. And finally, there's endpoint decomposition, which traces the final reports, such as regulatory filings, back to the raw source data to ensure transparency and auditability. So this is vital in compliance-heavy environments. So the common thread across all these types is the flexibility. So enterprises need to reconcile data at multiple levels with different logic across near real-time or batch pipelines. So now let's look at why reconciliation tools, the legacy tools, are no longer sufficient, and why organizations are shifting to modern platforms like Datagaps. First, these tools, the legacy tools, have a narrow use case. Many were built 15 to 20 years ago, maybe for finance-specific scenarios. They don't support an analytics, data quality validation, or reconciliation across APIs, data lakes, or cloud data warehouses, all of which have come into the data environment. So as a result, they lack the flexibility required in today's data ecosystems. Second, most are on-premise, making them hard to scale or integrate with modern cloud-native stacks from, say, AWS, Azure, or Snowflake. So this drives up the infrastructure costs and delays support for new data pipelines. Third is the manual setup. The rules setup is a major barrier. So creating the matching logic often demands coding skills or tool-specific expertise. And exception handling is also manual, leading to higher error rates and slower resolution. And fourth, legacy tools lack the built-in intelligence. There's no feedback loop or machine learning or AI to learn from the recurring mismatches of data. So teams end up wasting time fixing the same issues repeatedly. And finally, legacy tools suffer from the blind spots. They validate after the fact, cannot reconcile across silos, lack end-to-end traceability, leaving organizations exposed. So modern reconciliation demands the flexibility, the scalability, the intelligence, and the ability to do continuous validation. So let's explore why the shift away from legacy reconciliation tools is not just beneficial, but necessary. So first is, of course, as I mentioned, data complexity has grown. We're no longer dealing with just structured data from ERP systems. So today's environments include APIs, data lakes, cloud native platforms, handling unstructured and semi-structured data. So reconciliation tools must operate across all data types, not just flat files and do batch jobs. The second, automation is essential. The scale of modern data pipelines make manual validation not scalable, and legacy tools can't keep up when data volumes spike or schemas change. And modern tools like Datagaps automates this whole matching and anomaly detection, root cause analysis, and this frees up teams from all this manual error-prone workflows. Third, compliance standards have evolved. Regulators now demand full traceability, including the lineage, the rule history, and the resolution logs, not just the static audit files, which they used to submit earlier. Now, Datagaps supports this continuous compliance with built-in lineage tracking and automated exception handling. And fourth is the integration with DevOps and DataOps is now expected. So organizations need reconciliation that works with the CI/CD pipelines, supporting real-time monitoring, enabling automated testing, and legacy tools weren't built for this. So Datagaps, by contrast, is API first and cloud ready. And finally, modern enterprises need true to end-to-end reconciliation from source systems all the way to the reports, and with real-time or near real-time anomaly detection and support for data-driven decisions. So Datagaps makes this evolution possible, shifting teams from reactive, fragmented workflows to more intelligent, automated, and continuous validation. So this slide showcases a key differentiator of the Datagaps platform. Its ability to turn reconciliation mismatches into long-term data quality improvements. So traditionally, reconciliation has been a reactive activity. A mismatch is flagged, someone fixes it manually, and the cycle repeats. So Datagaps breaks this cycle by introducing a feedback loop, where every issue becomes an opportunity to strengthen your pipeline and enhance the data quality. So let me give you an example. So if mismatches are caused by, say, invalid zip codes, you can instantly create a rule like zip code must be 5 digits and not null. So now this rule becomes part of the pipeline, automatically preventing the reconciliation issue in the future runs. So over time, these rules compound, boosting the data quality metrics across the environment. So it's not just about detection, it's about prevention and continuous improvement. And this is just not for engineers. So with AI-assisted rule creation, where users can describe rules in plain English, like identify duplicate emails with different customer IDs. So Datagaps generates the underlying SQL or the logic, and this empowers many teams, the QA teams, the business analysts, and the data stewards as well. And you can also track progress, monitor the data quality scores, define domain-specific targets, and view the trends over time. And lastly, Datagaps offers issue classification and resolution workflows with built-in audit tracking. So turning reconciliation into a self-improving system that gets smarter with every run. So let's walk through a real-world reconciliation use case in financial services. So one of the most demanding industries. So a global investment bank operates a complex ecosystem with trades across multiple platforms, settlements to the SWIFT system, SAP-based general ledger systems. Their legacy reconciliation tool managed the basic trade to position checks but missed the pipeline level issues. So breaks were often detected late, requiring a number of hours of manual investigation across multiple teams. So the bank adopts Datagaps to modernize reconciliation across three layers. First is the transaction level validation. So the trades and positions are validated across the front, middle, and the back office systems. The subledger is compared with the general ledger, and Datagaps ensures that there's alignment between the detailed transactions and the general ledger entries, enabling any kind of audits on a regular basis. And exception management. So automated workflows categorize the mismatches and route them based on the risk and the transaction type. So the impact was significant. So reconciliation became a continuous process instead of an end of day, manual process. The manual investigation of any errors dropped. Auditors could trace the data lineage, transforming the compliance reporting, and the profit and loss and risk reports accuracy improved and boosting the confidence across multiple teams. Using AI-assisted rule generation, the recurring issues were created into reusable rules, driving continuous efficiency. So this is how Datagaps goes beyond faster reconciliation. It delivers trust, it delivers compliance, and the scalable control over financial data. And then let's look at how data reconciliation also plays a vital role in a healthcare scenario, where accuracy impacts not just the efficiency, but also compliance, reimbursements, and the trust of patients. So a large hospital network struggled to synchronize data across its health record systems, its billing platforms, and the insurance claim modules. So each are from different vendors, and the result was that there were mismatches between the health record entries and the billing records. There was high claim denial rates from CMS, the Center for Medical Services, Medicaid services, as well as commercial insurance. And there was gaps in APCD and CMS compliance. And hence there was revenue leakage due to all this inconsistent data. So Datagap solved this issue with multi-layered approach. There was field level validation, ensuring that there's alignment between fields such as patient ID, the ICD or CPT treatment codes, and dates. There was claims readiness scoring, and that predicted the success of claim using BI validator. There's real-time monitoring with flagged anomalies such as invalid codes or incomplete records. And there's automated compliance checks that align the submissions with state and federal regulations. So the outcomes were measurable. There was a reduction in the number of claim rejections. There was like 22% reduction, faster reimbursement cycle. There was a lower audit burden through centralized logs and lineage tracking. And all this shows that reconciliation in healthcare isn't just about matching the records. It's essential for revenue of the healthcare system, the regulatory compliance, and overall operational excellence. Now, we talked about financial services, we talked about healthcare. And so for anyone in either of these industries or in any other industry, here's a three-phase roadmap to maximize the impact from adopting these kind of systems. So the first is the short term, from say 0 to 6 months, where you're establishing the foundation and generating some quick wins. You start with a tool like an ETL validator and data quality monitoring on some high priority data pipelines, like financial reporting, compliance, or patient billing. You target 5 to 10 rules for matching, duplicate detection, and profiling. You set up dashboards to track the data quality score. You integrate with tools like Slack, Jira, or ServiceNow for basic alerting and workflow automation. Next, you move to medium term, which is say a year into the adoption, where you set up for automation and scale. So you expand to more pipelines, add BI validator for analytics validation. You automate the exception handling with severity based workflows. You use synthetic data generation to test the edge test cases. You leverage the auto rule generation and build a cross functional governance team that includes IT, compliance, as well as analytics. Long term, you optimize this whole process and generate more insights. You adopt machine learning based monitoring to catch any unseen anomalies. You extend the reconciliation to an external facing systems like claims or supply chain APIs. You generate KPIs for governance dashboards. You conduct quarterly rule reviews and SLA based audits. So this kind of roadmap, where you have three different stages, delivers early wins while building a long-term framework for enterprise-grade data trust. So with someone like Datagaps, reconciliation becomes a continuous improvement journey. Now, I will turn it over to my colleague to show a demo where we'll walk through how Datagaps transforms reconciliation with all these different features like endpoint decomposition and so on. So, Shubhanshu, over to you.
Thanks a lot. Let me start by sharing my screen. All right. Thanks for that. So yeah, we'll start exactly where Anand left off. And so in today's demonstration, we'll be looking at a few use cases from a surface level depth to understand where exactly reconciliation and how exactly reconciliation works and functions in true test cases. We're going to discuss a bit of Lineage. We're going to discuss some data quality controls and how we can create these rule sets from reconciliation using an AI-assisted loop in a proper CI/CD process, so to speak. And that is exactly what we will be jumping right into. There's just a few things that I want to discuss real quick before we get into the nitty-gritty details. The application can be installed and deployed within your infrastructure itself, if you need to. And being primarily Spark-based, the application can support a great number of connectors inherently. You see, we have JDBC connectors, flat files, BI tools, and the key aspect is, even if your architecture, which is going to be complex in nature, has multiple hops across multiple systems, the application can easily work with cross-environment hops as well. And this is what you will see within some examples. We are primarily Spark-based. That helps us with a good amount of scaling. Horizontal scalability is one of the key factors of our application. And this is one of where we'd like to take a pause here. Next thing I'd like to quickly discuss is a few use cases that kind of build up the case of what reconciliation really means. Of course, what Anand was discussing a while back was how reconciliation is part and parcel of TQ, and you cannot have one against the other. The product has a similar philosophy as well. There are two sets of validations that the end user can work with and without one another. This is quality-based validation, which involves data quality rules that we will take a look at shortly. This involves machine learning-based analysis, and this also involves profiling, where we understand what the data set looks like, appears to be a proper profile of aggregates and other systems like patterns and distributions, and keep track of them across time. The other type of theory that we would like to cover is reconciliation. Again, this is what the entire webinar is about. And this covers data-to-data comparisons, a full data reconciliation compare, some metrics compare, a bit of metadata comparison, as well as multiple data compare sets across multiple hops. And the rest of the notes aren't terribly important for this particular webinar, but it goes to show that the application can work with a variety of sources. You have the option of processing the data using pre-validation, SQL, Python, Scala, or using the same as post-validation use cases. And of course, you can save the records back, or which could be the mismatched records, which could be the matched records, and a variety of those. In our current example, we'll start pretty simple, and then we will start to make some complexities function. You'll see that we are working with a data comparison node. The problem statement is where we are working with a singular hop from one system to the other. The same aspect can be done between APIs to databases, file work against DB, DB against another DB, and every permutation and combination scene. The problem statement is that we have dimensional objects, in this case, which are being transferred from one system to the other. And we'd like to make sure that this transfer, that is without any transformation logic, is valid. To do this, we introduce data compare. This is a node that takes care of data type conversions, data column name mismatches, extra columns present in one versus the other, thresholding, and a lot of other hassles that you have to deal from a manual perspective. There's a lot that you can customize within the system inherently as well. The end result is not just a call out of what the mismatches look like, but a proper segregation of good and bad records into definite data sets. This is critical. As you can imagine, just finding out, say, mismatches is not the end of the story for a data engineer. You might want to process these mismatches. You perhaps want to go ahead with only the good records. And if you have a different sort of mismatch, like in this case, only in B refers to records which have not successfully been migrated, you might want to have some appending or other logic associated. But the key aspect is that you might want to save mismatches or any of the other use cases right here in a different location. And it's as easy as defining, say, differences to be saved in, let's assume, S3 bucket. And now our test case has been modified to ensure that if there are reconciliation issues between any hop, these reconciliation issues can be caught. And if there are issues, well, there are mismatches or pending or appending records can be pushed ahead. And of course, if there is a notification service that you need, a Jira ticket that you have to raise, or maybe send some notifications back to Azure DevOps or any other system, that is possible as well. Now let's look at the same use case except from a different perspective, and the perspective in question is of Power BI. Then we will jump into a few specific types of use cases. Within Power BI, again, the one use case I would like to focus in on is the one that we'll be looking into, where we want to make sure that we can backtrack from the reports how exactly these test cases are generated. So to this end, let's open up this use case right there. And you'll see I have a Power BI report that's already loaded in. Again, BI report in its own right, it's entire different types of validation use cases as well. There's validation in terms of the data, there's validation in terms of the metrics, the visual elements, and everything in between as we wait for this report to be loaded in for the first time. And we see that in this particular use case, what I want to ensure are numbers that I see within my BI reports have to be valid. Now, for the sake of time and for the sake of pace of this particular demonstration, I'm not going to delve too much into how we create these test cases in bulk, but I will suffice to say that there is a good amount of wizard and template creation process to help you automate the creation of these test cases that you're seeing. In an enterprise deployment, you won't be creating nodes individually. You will have wizards and templates which will be reused to create test cases in bulk and in spades. Back to our use case. We want to make sure that the numbers in our charts are valid, and the first step there is to make sure we can actually fetch the said numbers from our charts. We'll see that the application can actually get them directly from the BI report itself. This is not the underlying data model. This is not the underlying data set as well. If I apply a particular filter, the embedded report is going to be altered, and so are the data sets. Key aspect here is that the application also has support of applying these filters and slices in a dynamic fashion. And that's a rabbit hole which basically ends at ensuring that your reports are being valid for every permutation and combination of filters and slices that you would like to apply. It gets pretty deep, but it's a heavy BI use case. For our systems here, we don't really need to get into too much detail here. The key aspect is that we have exported records from the BI report. And now I want to make sure that I can compare them against golden records. Here, an Excel file represents my golden records, and this is a viable example, as sometimes you might have BI engineers or just BI folks sending the correct number or correct aggregation that they're expecting in an Excel file. So it's very valid to have an Excel file here. You'll see in other examples, we'll use databases. and this raw data right here still has to be aggregated. You cannot compare 1,000,000 records against an aggregate of 250. You need to create the aggregation logic. And to help you facilitate with this so that the process of test case creation is faster, we can use generative AI. Here I've used an AI system to just convert the charts that I got from my BI report into raw data from the raw data set. So I want to create the aggregation. And after a few prompts asking it to correct itself in specific locations based on the context I have that the LLM might miss, we get the query generated. And this query now illustrates the golden records that I have from my, say, the aggregation. So this is the aggregated golden records. Once again, we include reconciliation, which has all the issues and issue that resolving that in terms of column name mismatches, type mismatches, and others. And then we have a proper graph and, of course, segregation of good and bad records, which tell exactly what the mismatches look like. These mismatches are not being rounded up and there's no thresholding involved. This is to illustrate that that's the default. And of course, round up the values as well as define thresholds within the application if data latency is what you're looking for. When this test case is run, there are notifications automatically sent out. There are mismatches and other DataOps processes done. There's run histories associated, and each time you run a history, there's also a reporting section that works. And if you look at reconciliation in its true form, this is what it actually comes into. So this is a small part of a broader scheme where you might be receiving files from a different system and say raw files. Now these raw files are going to be cleansed before being conformed and before being pushed into a business data mart. The raw file in question in this case is a cash flow file that we are working with some policy and other systems. And the key aspect here is to illustrate that if you have these multiple hops, you can run validations across each and every hop. And this is what the basis of reconciliation works with in many use cases. We see here that we have a good chunk of mismatches within our initial load itself. So that is something that we can easily catch and say raise alarms for. And this tells the story that even if in subsequent sessions or subsequent hops we find our data to be accurate, that could be pretty inaccurate. We also see the use case of SQL transformation here. Again, we can use the Copilot to get there, and that's what I've done specifically by giving it the proper data set specification. It has created the query for me to make sure that the transformation logic that I'm applying is correct. Now, there's an entire side plot here, which I'll quickly come into because this comes into Lineage. So we'll open up our cash flow model Lineage. And you'll see that the application can keep track of what columns are associated with one another and how these columns work in tandem with their data sets. Of course, these can get pretty complex as well. I mean, this is just one example use case of a simple pipeline. You might have multiple tables and multiple columns associated between one another, and your lineage can look a little like this as well. Back to our example, the key aspect here is that we want to keep track of the lineage and we want to make sure that these hops are being done correctly. And if there are transformations, these transformations also have to be validated. That is the role that generative AI plays. Here I'm doing it from a manual perspective, but there are automated schemes within Mapping Manager right here, which can take into account the same information that I'm providing in plain text, either from an Excel file, from Collibra, from Unity Catalog, or a slew of other feature sets as well. And that's what our key aspect here is. We want to make sure that the transformations and the transform data sets are valid. And this can end all the way to your BI layer as well, where the same example that I've discussed comes into play. But in this example, I work with the BI report, a simplified BI report, and I make sure that the critical KPIs right there are being validated against the data model, against the business smart layer, and all the way down to the BI model layer itself. And here we see there's a huge mismatch. And again, that tells us the entire story in a nutshell. Of course, we want to make sure that data quality rules are also applied based on the reconciliation. And this is an example that has come up from a financial customer of ours where they wanted us to demo a few specific use cases. And the key aspect that came in was that use cases like this, where a particular contact number was expected in a set format because the functions and transformations that they were working with were not able to process contact numbers in any other format. So here, that's what you see. We found out this issue that yes, the contact number comes in multiple spaces. We even have profiling and other systems to get this understanding. But reconciliation told us that contact number was null for a good chunk of records. It was null because the function that we had defined was expecting a strict format validation right here in this particular format. And this is just one of the space. There's a variety of use cases that you can apply. And most of the data quality rule sets are zero code, as you can see. And even if they are zero code, They offer endless amount of customization due to the fact that the operators themselves can be customized. The end result of data quality rules across multiple dimensions and across multiple systems is a proper data quality score, a scorecard that is given at a rule level, aggregated to a table level, more on this later, and of course a proper segregation of good and bad records that tells exactly what is wrong for a particular data set, because we save the history, and if we want to, we can always backtrack and see if this is a repeat offender or if this is something that has come up for the first time for this particular record. There's a lot of depth that comes in which we can't get into, sadly, due to the interest of time. Going back to scores, we see data quality score being validated or created for an entire rule set, for an entire table, all the way to an entire system. So here data quality model comes in, where we see that in this case, it's an insurance model where we are applied a good amount of rule sets across multiple tables, across multiple columns as well. And you can, of course, zoom in and see exactly what particular rule set is failing and what particular rule set is causing issues between systems. So this one is a rule set. We were checking for the validity of a claim after a particular incident. These data quality rule sets, of course, are aggregated all the way to a system level where you can keep track of them across multiple dimensions. And as I've discussed earlier, if you want to keep track of repeat offenders versus new records, we do that inherently as part of checking the new bad records and the old bad records, as well as the records being resolved. This is the tip of the iceberg within our system. What we have covered today in this short demonstration is how the application can work across a lineage to keep track of every transition hop from one system to the other. And then we also make sure that the transition from one system to the other is keeping track of data quality scores. Just because you did not start with duplicates at the start does not mean you might not have duplicates after your transformation. So reconciliation and data quality go hand in hand throughout your entire lineage pipeline, all the way down to your BI layer. Once again, this is just the tip of the iceberg. We can also do visual comparison. We can also do complex hierarchical files validations and a lot more variety niche use cases. So if you have any questions specific to that, feel free to contact us. And again, Anand is going to discuss more about how to do that shortly. With that, I can conclude the demo. Thanks a lot, folks.
Thank you, Shubhanshu. That was very impressive. And thank you. So this is what we had Shubhanshu demoed, and I wanted to highlight that we have walked through how the different endpoints can be decomposed, tracing back the report's final values back to the full lineage, back to the source system, showcasing the full lineage. Shubhanshu showed you the lineage diagrams where you can visualize the system flow as well as the data quality controls applied at every stage, not just at the end. And then we have shown how AI-assisted rule creation, automated rule generation, turn all these mismatches into reusable logic, helping the teams continuously improve and reduce the future errors. So given that, we will now move to the next stage, which is at its core, reconciliation is about trust in your data and your systems and the decisions built on them. But to keep that trust, reconciliation must evolve from a periodic task into a more continuous, intelligent process. And Datagaps supports this shift with a platform that's end-to-end, covering ETL, covering BI, as well as data quality and handling the exceptions. It's cloud native. It's compatible with all the three hyperscalers, as well as Snowflake and Databricks. It is low code and intelligent for both technical and business users. It allows continuous learning. It turns mismatches into smarter rules that you have for data quality. It's compliance ready with full traceability and audit support. And the result that you get is fewer errors, stronger compliance, and better decisions. So whether you're reconciling subledgers in finance or aligning the health records and claims in healthcare, so Datagaps can help you build more smarter, trusted pipelines. So now let's take some questions. So Puja, were there any questions that we could talk about?
Yes, yeah, sure. First of all, I would really like to thank Anand for sharing how innovative enterprises are transforming data reconciliation, and Shubhanshu for an extensive demo of Datagaps DataOps Suite for understanding the same. Now, we're moving on to our set of questions that attendees have asked. So, very first question is, why is data reconciliation considered a strategic function, not just a compliance checkbox?
Yeah, interesting. Yeah, very applicable question. So, as I said, data reconciliation is not more than just detecting the mismatches. It plays a very key role, a foundational role in establishing the trust across different enterprises. And then you've got all these different requirements, SEC, HIPAA, FRB 1419, all these different new regulations. Then you need the full audit trail, the lineage, the traceability for all these regulations. And you have to do this across, as I said, across different hybrid data environments to ensure that what you're reporting is accurate, compliant, and you have the full transparency. Yeah.
Okay. Thanks, Anand. Next is, what are the key industry drivers pushing organizations to modernize reconciliation?
Yeah. So we have the regulatory pressure on one hand, and then you got the complex environments that, there are several new APIs that have come up, several new unstructured data formats that have come up that you have data in all kinds and forms across different platforms, and the speed of making these decisions have shrunk from becoming like from monthly checks into more real time or more continuous reconciliation, and that has become a necessity. And We have to ensure that any kind of audits that are done, the burden on the organization is minimal. And so showcasing where the final reports derive the raw data from, and ensuring that accountability all become very important. And that's why this is these drivers are pushing and modernizing reconciliation.
Great. Thanks. Anything to add, Shubhanshu, from your point of view?
No, I think he covered everything properly.
It covers well. Yeah, definitely. Okay, now next is, how does Datagaps improve over legacy reconciliation tools?
Yeah, we've had these older tools that have been focused on specific industries. Like, it started all in the financial services, and there were tools. I'm not going to name names here, which focused on financial services that have had a lot of adoption in the space. But then, there is this need for low code and no code workflows, more automation for all the validation that needs to take place, the exception handling that needs to take place. We want to continuously create new rules, execute those rules. And with all this AI coming into the picture, we want that feedback loop to be continuous. And so we also have AI being able to observe the data. There's this whole concept of data observability, and we want to incorporate that into the data reconciliation process. And of course, we are able to offer this because we are cloud native, and across we can be used across different environments, on-premise, cloud, such kind of hybrid environment. So that's the value proposition of leaving behind your legacy tool and moving to a more modern platform.
Great. Yeah, thanks. Thanks. Next is, what makes continuous reconciliation different from batch-based reconciliation?
Yeah, that's an interesting question, and that is, one of the key areas that we focus on. This continuous reconciliation process across the entire life cycle of the data, all the way from ingesting that data, transforming that data, delivering that data to reports. This continuous reconciliation process enables early detection of mismatches. They say the cost of recognition of errors goes up as you go up down the pipeline. And so early detection is key. And also the support for CI/CD processes or DevOps processes and the integration with that enables us to evolve as the rules evolve and scale based on the needs of the organization and ensure that the data is accurate and trustworthy.
Right. And now, next is you have discussed many industries as use cases. So one of the candidate asked that how data gaps handle field level mismatches in complex environments like healthcare.
Yeah, we have quite a few healthcare customers, and so there are several field level integrity checks that I've done. For example, patient ID is a field, diagnose code like ICD-10 is another field, any kind of medical procedure code like CPT codes are another field. So reconciliation helps ensure that the data meets those standards, the compliance standards from organizations like the Center for Medicare Services, the CMS, right, or a state level APCD code. So all those regulations require the completeness of the data. There are thresholds for accuracy, and there are several requirements. And by ensuring that we are compliant with all those regulations enables a healthcare organization to minimize any revenue loss from, because their claims were denied or, there's additional system administrative overhead. So it ensures that whatever claims they have are ready to be actually result in revenue and ensuring a strong audit trail for all the regulatory agencies.
Great. Next is what is endpoint decomposition and why it is important.
Yeah, so this is, Subhanshu just showed this report where you can decompose the different pages within the report, the different visuals within the report, the filters within the report, and you can trace it back to the source systems and all the transformations that the data has gone through. And this is very important for ensuring that the data or reports are ready for any kind of audits. It makes them very transparent and explainable. It supports any kind of root cause analysis that helps the regulators who are reviewing the reports understand the reported numbers and the lineage of those numbers. It basically creates a more explainable solution around where the data is being sourced from.
Okay. And the last question is how does Datagaps empower business users in reconciliation process?
Yeah, that's a really good question. Today's age of AI, and we want to remove the technical barriers. Everyone should not be like a SQL coder. So Datagaps wants more people like data stewards and other less technical people also be involved in this reconciliation process using in natural language. And the Datagap system converts this into the SQL and other rules. It ensures, it democratizes this whole process and compliance officers or analysts can get involved to define the validation rules without actually writing the code. So users can tag the issues, they can track recurring problems by individual domain, and contribute to the whole feedback loop that we talked about that improves the rules and the coverage over time.
Great. Thanks, Anand. And this is the end of the Q&A sections that we have. Now it's time for CTA.
So thank you everyone for joining us. So hope you like this whole AI-driven reconciliation process and how it enhances the trust, accuracy, and compliance across this whole complex data ecosystem. So if you want to see the Datagaps DataOps Suite in action, scan that QR code for a free demo, or reach out to us, explore our white papers and case studies, and we are here to help you modernize the data reconciliation process. Thank you.
Thank you. And moreover, if you have any more queries to us on data reconciliation on any other testing automation sites, please do write to us at contact@datagaps.com. And thanks for joining the webinar. Thank you, everyone.
Thanks.